initial investment for commercialization, and 54.5% of the producers having problem on lack of knowledge on commercialization. And towards the objective two, to find the compost quality, only one sample deviated from the SLS standard in order and texture determination. Under the color determination, all samples compiled with the SLS requirement. According to the SLS requirement, the moisture content should be less than 25% in the dry basis. Here, only 18% of the samples compiled with the SLS requirement. In sand percentage, only 18% of the samples compiled with SLS requirement. In the particle size distribution determination, all samples compiled with the SLS requirement. In pH determination, also 91% of the samples compiled with SLS requirement, and the electrical conductivity should be between 0.5 to 4 decisiemens per meter. Here, only 82% of the samples compiled with SLS requirement. The CN ratio should be between 10 to 25. Here, 64% of the samples compiled with SLS requirement. In phosphorus content determination, all samples compiled with SLS requirement, and in the potassium content determination, only few, the 27% of the samples compiled with SLS requirement. Finally, the weed seed contamination effects determination, all samples compiled with SLS requirement. To estimate the potential compost production in Kilinochchi districts, these are the data used. Major crops and their extent in Kilinochchi data were collected, and the organic manure required for the organic farming for each extent was calculated. It's around 172,134 tons. The total amount of compost can be produced from locally produced waste. It's around 515,676.51 tons. So we can clearly say that there is more enough amount of compost can be produced from locally produced waste to satisfy the crop requirement in the Kilinochchi district. So the conclusion from the questionnaire survey, most of the commercial producers practicing the open space type of compost system that may affect the quality of the compost. 63.6% of the producers participated in training programs done by the Department of Agriculture and the Faculty of Agriculture. 36.4% of the producers need training programs to improve themselves. Main problems faced by the commercial producers in Kilinochchi district are lack of initial investment for commercialization, less availability of inputs due to non-systematic collection, lack of knowledge on commercialization. Towards the quality analysis of compost, none of the commercial producers compile all SLS requirement in quality assessment. Therefore, all need further training programs to enhance the quality of compost in commercial level. Here you can see the moisture content, sand percentage, nitrogen percentage, CN ratio, and potassium content should be improved. So the suggestions are provided to farmers to improve the quality. Moisture content can be easily reduced by frequent drying. By reducing the sand percentage, nitrogen percentage, and CN ratio will be increased. It's better to use polythene or cement floor to reduce the sand percentage. Potassium content should be increased by addition of potassium-rich materials such as ash, banana peel, or banana pseudostem. So from the potential production of compost in Kilinochchi district, production of compost from the locally available waste resources was more enough to satisfy the crop requirement in Kilinochchi district. We can supply excess amount of resources to nearby district to encourage organic farming in Sri Lanka. Way forward, estimate potential production of compost in other districts of Sri Lanka. Plan research to improve potassium content of commercial level compost. Thank you.
Madhu sir?
Yes, sir.
Your data collected only from the producers, no?
Yes, sir. Commercial level compost producers.
Another thing, they are using different types of raw material, is it?
Yes, sir.
Which one is good quality from your analysis? Animal waste or kitchen waste? I think you mentioned so many, 3 or 4 type of raw material, no?
Yes, sir. They used a wide range of materials, sir.
Which one is good quality or better quality?
I collect one vermicompost, sir. It's resulted the better ones. The vermicompost.
Vermi. Bhumi
Yes,
Mani.
all the SLS requirements are satisfied.
Others are not.
Yes, sir.
Okay, okay, go ahead. Good.
Thank you, sir.
Hello, Madhina.
Yes, ma'am.
When you have in your conclusion, you are told that that infections they are protection containing in other components. Like that, here you have used the trained people compost. No, is that what they have used?
Sorry, ma'am, can't hear you clearly.
That is, you have mentioned in the conclusion. Can you hear me?
Yes.
You told to improve the potassium content in the farmers those who are produced without having the training. They have to apply some ash potassium rich components.
Yes, ma'am.
But you have compared it with the compost prepared by the trained people. So the trained people, what are the components that they have used to make high amount of potassium in that compost? Have you found anything? High content of potassium. In addition to vermicompost, any compost, have you added high amount of potassium?
Moisture content is the major problem. Is in other.
Potassium was low. No? I observed in your table. So moisture content, you are telling they have to try it. No?
Yes, ma'am.
How they can try that after producing the compost, they have to try. Is that the regular?
Yes, ma'am. After drying, they want practice frequent drying of by mixing.
Yeah. And
They want to turn.
but trained people, what they are doing? To have the low content.
Sorry, ma'am. But
The trained people that you are supplied the compost from the trained people, it is from the trained people, those the training and also the local people, no?
yes, ma'am.
So in the trained people, they are the flow in terms of compost. But where they, what that practice they have used to reduce the are they also do the drying after producing the compost?
They can practice composting in under roof areas.
And then,
Under roof system.
and then,
In the rainy areas, they can practice under roof system composting.
under.
Yes.
That's it. That is due to rainfall. Okay. Any questions? Thank you, Madhina.
Thank you.
Good morning, Dr. Govinder.
Yes, good morning. Good morning.
Now only we just now only we have started only one presentation that we have completed.
Okay.
For your panel, we have an additional three have to be completed. Huh?
Okay, okay, better.
Okay, okay.
Okay.
The second presenter, Udarni. I hear.
Yes, madam.
Yeah, your presentation is production of quality compost using underutilized residues and waste with spirulina and Panchagavya. You can now share your presentation.
Good morning to all. I'm going to present about production of innovative compost using underutilized residues and other waste with spirulina and panchakavya based on paper ID ISA 022. Let's move to the introduction. Organic fertilizer is environmentally good as well as economically sustainable opportunity for farmers. If organic fertilizer could be manufactured at low cost using available waste material, it will be beneficial to farmers. Composting provides the chance to convert organic waste into inputs for agricultural production. Compost is a humus-like substance formed by the aerobic biological decay of organic matter. It increasing yield, act as buffer to changes in soil pH, increasing the biological activity of the soil, improving soil structure, porosity, and the density. Let's see some details about the Spirulina subsulsa. Spirulina is a cyanobacteria. It improves the soil fertility by excreting of growth-promoting substances like hormones, vitamins, and amino acids, increase water holding capacity, increase in the soil biomass after their death and decomposition. Panchakavya is most important thing of my research study. Panchakavya is a specific preparation created from 5 byproducts of cow that has the ability to promote growth and immunity in plants. Panchakavya increase the decomposition rate by reducing the composting time. In previous study revealed that low-cost organic powder fertilizer formulated using Spirulina azolla, coconut leaf, palmyra leaf, banana pseudostem has positively influenced on growth and yield parameters of selected crops. But they faced some difficulties like the grinding organic sources to formulated powder fertilizer, unwanted electricity cost, powder fertilizer application difficult and loss high, and processing issues. To overcome these kind of problems, the better solution is composting. The problem statement: in northern province, nutrient-rich palmyra and coconut leaves are abundantly available. Anyhow, those are underutilized resources. Food processing unit, which is located near to the faculty, generated huge amount of fruit waste. Waste disposal is a big problem. High usage of inorganic fertilizer cause health and environment problems. And this slow decomposition rate of composting is a problem. Let's see the overall objective of my research study: to produce innovative quality compost using locally available waste material in association with Spirulina subsulsa and the Panchakavya. Specific objectives are to analyze the nutrient content of waste material and other inputs, to identify suitable treatments for produce quality compost using available resources and CN ratio, analyze the nutrient content and physical properties of compost, and compare the quality of produced compost with SLA 645 to access the potential of Panchakavya and decomposition rate. Let's see the materials and methodology of my research study. These are the raw materials of my research study: Spirulina azolla, fruit waste, yard waste, banana pseudostem, Panchakavya, palmyra leaf, cow dung, and coconut leaves. Raw materials allowed to air drying within 1 week. Raw materials preparation: Spirulina culturing was done in research study. Added culturing media for semi-mass culturing. And fruit waste and yard waste chopped by manually, and the palmyra leaves and banana pseudostem chopped by using machine. Cow dung, cow urine, cow milk, curd, and ghee are the basic components of the Panchakavya. And we did analysis of the raw material. We did 2 analyses: organic carbon and loss on ignition method, and nitrogen content gel dal method. Based on the CN ratio of the raw materials and availability of raw materials, treatments were decided. We decided 6 treatments. Treatment 1, 25% banana stem, pseudostem, 25% palmyra leaf, 25% coconut leaf, 24% azolla, 1% Spirulina, and 5% Panchakavya. Treatment 2 is similar than the treatment 1 except Panchakavya. Treatment 3, 12.5% banana pseudostem, 12.5% palmyra leaf, 12.5% coconut leaf, 12% azolla, 0.5% Spirulina, 50% cow dung, and 5% Panchakavya. Treatment 4 is similar than the treatment 3 except Panchakavya. Treatment 5, 30% fruit waste, 30% yard waste, 40% cow dung, and 5% Panchakavya. Treatment 6 is similar than the treatment 5 except Panchakavya. Composting experiment was done by using composting bin method. Composting material selected based on CN ratio. Experimental design was completed randomized design. 6 treatments and 2 replicates used. Temperature measured by using compost thermometer, and water in 2 days interval, and monitoring was done by using hands weeks method. Turning was done 2 weeks interval. Maturation and storage: allowed to maturation 8th week to 10th week. After then sieving by using 4mm sieve, then weighing, packing, and the finally storage. Sampling of the compost, we did 6 steps, 5 random locations selected, then collected the samples 100 gram, mixed well, quartering method used, and representative sample, and finally analysis. Analysis, we did 2 analyses, 2 main analyses, physical analysis and the chemical analysis. In physical analysis, color, odor, moisture content, sand content, and decomposition rate. Chemical analysis, pH, total organic carbon, total nitrogen, total phosphorus, and the potassium. Statistical analysis, the data was statistically analyzed using statistical analysis software version 9.1.3, and Duncan's multiple range test was used to compare means. This picture shows you how we did physical and chemical analysis, moisture content, total organic carbon analysis, total nitrogen analysis using digestion unit and distillation unit, total potassium analysis using flame potentiometer, and total phosphorus analysis using spectrophotometer, and decomposition rate, color determination by using Munsell color chart, and sand content, and finally pH. This is the most important part of my research study, results and discussion. This chart shows you the initial quality of the raw material measurements, carbon amount, we analyzed nitrogen amount, and the moisture content of 8 raw materials. Moisture content of the all treatments also we recorded, initial moisture content and the after 8th week moisture content, color and smell determination. All the treatments were odorless, and the color, treatment 1 and treatment 2 dark brown color, and the others blackish brown color. And sand content of the compost, treatment 5 was recorded the highest sand content of the out of all treatments, and treatment 1 was recorded the lowest sand content. According to the SLS, the final compost should have the sand content below the 10%. All the treatments complied with that except treatment 5 and treatment 6. Reason for that, they contain yard waste and fruit waste. Yard waste and fruit waste contain some sand particles, especially yard waste. And the pH of the compost, treatment 6 was recorded the highest pH, and the treatment 3 was recorded the lowest pH. According to the SLS, the final pH should be have 6.5 to 8. In between 6.5 to 8.5. All the treatments complied with that. And the decomposition rate, the treatment 5 was recorded the highest decomposition rate, and the treatment 2 was recorded the lowest decomposition rate. According to the SLS, the final pH decomposition rate of the compost should above the 8%. All the treatments complied with that except treatment 1 and treatment 2. Reason for that, they contain palmyra leaf. Palmyra leaf have high cellulose content. Then reduce decomposition rate, and when we talk about the treatment 1, treatment 3, and treatment 5, they contain panchakavya. When compare treatment 1 and 2, treatment 3 and 4, and the treatment 5 and 6, the treatment 1, 3, and 5 have high decomposition rate than others because they contain panchakavya. And organic carbon content, treatment 1 was recorded the highest organic carbon content, and the treatment 6 was recorded the lowest organic carbon content. According to the SLS, the final compost organic carbon content should above the 20%. All the treatments complied with that. And nitrogen content, treatment 1 and 3 was recorded the highest nitrogen content, and the treatment 6 was recorded the lowest nitrogen content. According to the SLS, the final compost should have the nitrogen content above 1%. All the treatments complied with that. And the CN ratio, treatment 4 was recorded the highest CN ratio, and the treatment 5 was recorded the lowest CN ratio. According to the SLS, the final compost CN ratio should have 10 to 25. All the treatments complied with that. And the phosphorus content, treatment 2 was recorded the highest phosphorus content, and treatment 4 was recorded the lowest phosphorus content. According to the SLS, the final compost phosphorus content should above this 0.5%. All the treatments complied with that. And the potassium content, treatment 1 was recorded the highest potassium content, and treatment 6 was recorded the lowest potassium content. According to the SLS, the final compost potassium content should have about the 1%. All the treatments complied with that. Let's see the conclusion. The results of the study revealed that panchakavya has the potential to increase the decomposition rate. 5% Panchakavya increased the decomposition rate in the range of 4 to 14%. This chart shows you how treatments complied with the SLS with chemical and physical properties, except sand content and the decomposition rate. Other chemical and physical properties shows the all the treatments. In treatment 5 and treatment 6 not complied with the SLS in sand content, and treatment 1 and treatment 2 not complied with the decomposition SLS in decomposition rate. And out of 6 treatment, the highest nutrient content was recorded in treatment 1, and all SLS requirement were complied in treatment 3 and treatment 4. Suggestions. This study was conducted in small scale, that's mean bin method. It can be tested in large scale, that's mean compost file for commercial product of quality compost. In this study, 5% Panchakavya was used. Different concentration of Panchakavya solution can be reduce the compost in time. These are the references of my study. Thank you for your attention.
Thank you. Now the presentation is open for discussion.
Hello, Aparna.
Yes, sir.
You did only with 5% Panchakavya, is it?
Yes, sir. Yes.
You have to go for further studies.
Yes, sir.
Then any idea about cost?
Sorry, sir.
The cost of production of 1 kilo? Any idea in any treatment? What are the cost will go for the produce 1 kilogram of your treatment, any treatment? Do you have any idea? All are the cheapest material?
Yes, sir. All are the cheapest material, but Panchakavya got high cost.
High cost, no?
Yeah, producing Panchakavya is curd, ghee, the ingredients for the Panchakavya.
Yes. When for further studies, you have to expand, no?
Yes, sir.
Everything. Okay.
So here also the cost effectiveness will be that the cost for the treatment 1 is high, no? Anyway, that nutrient content is high.
Yes.
But the treatment 3 is accepted with the SLS standard, no?
Yes,
So
yes,
in
madam.
that you have reduced the component all composition by half, and also Panchakavya by half, no?
Yes, madam.
But the nutrient content is low. What is the reduction? The rate of reduction is that high?
Sir, madam.
The rate of reduction in between T1 and T3 nutrient content, because we have to consider the cost and nutrient content, no? So with that, is that cost effective? We have to check. That's why I'm asking, because do you have an idea? Can you understand what I'm telling? Because the treatment 1 nutrient content is high.
Yes, madam.
And treatment 3 SLS standard, fulfilling the SLS standard.
Yeah.
At the same time, in treatment 1, you are using more Panchakavya. So that is the costlier one. But in treatment 3, you have used half amount of Panchakavya than T1. So I am asking you, which will be the cost effective by giving the nutrient? Because if the nutrient change, difference in nutritive content in T1 and T3 is not much high, we can go for 3, because that will be cost effective and nutrient content will be high. That's why I'm asking, do you have any idea about the cost?
I think T3 is the cost effective one.
Yeah. And also you have to consider the nutrient content also.
Yeah. And decomposition rate also, the one somewhat reduced than the T3, you know.
T3?
Yeah, Palmyra leaf contain one treatment.
Yeah, that is CN ratio is normally high.
Yeah.
CN ratio is high, so the decomposition rate will be low.
Low.
Yeah, so we can go for T3 rather than T1, I think.
Yeah.
Yeah, okay. That is my suggestion. Anything to be clarified from anybody? Dr. Duminder, do you have any?
Okay, yeah, it's very interesting study, and if I see the data, especially the nitration, the results say it's really having a good values around 2 or greater than 1%.
Yeah.
Now, my concern is regarding the phosphorus determination. Now, what is the SL standard in phosphorus? Is it available phosphorus or total phosphorus? The percentage.
You went for total, I think. What is your phosphorus analysis? Is the total or available?
Total analysis, total
Yeah,
phosphorus.
yeah, the student has done in total phosphorus.
yeah,
I got it. Now, what is the
SLS?
SL standard?
SLS?
Sir, total phosphorus content SLS standard. The final compost should have about the 0.5 percentage.
Is it total or available? My question is that.
Mostly available, I think, no?
Yeah, to my understanding, it has to be available. The percentage 0.5 is the demarcation point. Yeah, so please check out that. Otherwise, yeah, somewhat the results might be misleading because there is a clear difference now in between the available and total predetermination, right?
Okay, sir.
Please check out that. It's really good study. Thank you.
Thank you, sir.
Thank you.
Thank you, madam.
Thank you. Then we'll move on to the third presentation by Lavina. Yes, Lavina. Nitrogen enrichment of organic compost through different formulated steps.
Yes, madam.
Okay, you can share your presentation.
Today I am going to present about my research presentation under the heading of nitrogen enrichment of organic compost through different formulated steps. I am Lavina Srinivasaraju from Faculty of Technology, University of Jaffna. Let's start with the introduction. Compost. Compost is partially decomposed organic matter. The mixture consists of largely decayed organic matter and is used for the fertilizing the land. Compost is important for enriching the plant in organic ways. The compost is made from crop residues and or animal manure are incubated several days ago.
Hello, Lavina, your sound is not here. Unable to hear.
Used by the farmer for agricultural activity. Now the government also encouraged to make the compost use the compost as the organic fertilizer. The major issue of the compost having the low nitrogen content and the commonly used compost having about low 1% of the nitrogen, so that the study will help to enrich the nitrogen content of the compost. Then the justification, compost is the organic fertilizer, and now the country tries to turn the agricultural activities as organic, so that commonly compost is used by all types of farms, so that enrichment with nitrogen content of the compost is needed. Normally, compost having the low nitrogen content, the experiment with the help of the different raw materials to take the enriched output will help to the farm. Then the general objective to enrich the compost with the help of the different steps to produce the compost which is useful for the farmers to reduce the use of the inorganic fertilizer. Then the specific objective to improve the nitrogen content of the organic compost through different formulated steps to determine the proper way for the nitrogen enrichment of compost making, to find out the nitrogen content, to find out the nutrition content of the compost. Then material and methodology, study location. This study was carried out on the farm of Regional Agriculture Research and Development Center, Kilinotsi, during the February 2022 to May 2022. The laboratory analysis was carried out at RARDC, Iranimadi Junction, Kilinotsi. Then the raw material. In here, there are three types of raw materials were used. First one is the plant materials. Under the plant materials, Lurelia and wild card sunflower were used. And the another one is plant animal materials. Under the animal material, cow dung and horse manure were used. Then the another one is final one is other materials. You all know compost was prepared with the locally available material. It's used for the farmers also. So that the other materials used here. So the other materials are pedestal, banana solution, leaves, biochar were used. For the usage of biochar of preparation of the biochar, Undania model structure was prepared, then pedicast was allowed for the pyrolysis process, then end products was come out as biochar. Then preparation of the decomposition solution, weigh the cow dung and add the cow urine and mix well and allow to the 14 days. Then preparation of the fish meat, collect the fishes and add juggery and allow for the 21 days. Then preparation for the panchakarya, fresh cow dung was mixed with the cow ghee and allowed for 4 days. After the 4th day, cow urine, cow milk, cow blood were added. Then jaggery and coconut tender and rice and banana were added to the solution. Then the solution goes to the container. The container was covered with kept tightly, then allowed for the 15 days with fermentation. Then preparation of the suitable land area. The suitable land area was selected and cleaned with the machinery. And then preparation of the model structure for the compost. Model structure for the compost was created with the locally available material, and the bottom part of the model structure was covered with a polythene to avoiding the sand mixing. Then preparation of the raw material. For the raw material preparation, plant material like Lurelia and wild sunflower were chopped with multi-purpose for increasing the decomposition rate. Then raw material analysis. For the raw material analysis, moisture content, total organic carbon, total nitrogen, total phosphorus, total potassium were checked. Then the composting process, all the materials were weighed and put it in the product structure and then after that, raw materials were allowed for the composting. The composting process, the raw materials were prepared. After the preparation of the model structure, the raw materials were put it into the model structure and mixed with and covered with a polythene and allowed for the maturation. After the second week, first turning was done. After the maturation, the compost was allowed for sun drying. After the sun drying, compost was chilled. After the chill, the compost was allowed for the enrichment. Finally, after the enrichment, the samples were collected for the analysis process. Then we will move to the treatment. For the treatment, in here, for the treatment 1, 2:1 plant material and to animal material. Animal none was moisturized with the water. In treatment 2, 1:2 plant material to animal manure and moisturized with water. Treatment 3, 1:1 plant material to animal manure moisturized with water. Then these are the other category. The moisturizing solutions were different. The 2:1 plant material to animal manure, but the moisturizing solution is decomposition solution. And treatment 2, plant material to animal manure 1:2 and moisturizing decomposition solution. Then treatment 3, plant is to animal manure 1:1 and moisturizing decomposition solution. For maintaining the composting file, temperature and moisture were checked and turning was done after the second week. For the composting analysis, sand content, moisture content, color, odor, pH, EC, total nitrogen content, total phosphorus content, total potassium content were checked. For the pH analysis, pH was analyzed with the pH meter, EC was analyzed with the EC meter, total nitrogen content was analyzed with the Held-on method, total phosphorus content was analyzed with the spectrophotometer method, total potassium analyzed checked with the flame photometer method, total organic carbon was analyzed with the what is the black center. Then we will move to the results and discussion. First one, moisture content. When seeing the treatment shows that T1 having the low moisture content than the T2. The decomposition solution helps to maintain the moisture here. Then seeing the ratio of the raw material, the ratio of the raw material shows the different results in each method. In here, the moisture content is high in equal ratio of the raw material. Moisture content is different due to the moisture holding capacity. When comparing with the standard is greater than 25%. Treatment 1 and treatment 1 is named moisturizing with the water, and C3 is means equal, it means 1:1 ratio having to a little bit lower in the lower tree. Then temperature, the old compost file showing the rising temperature after the raw materials were mixed. Then sand content, the treatment shows that T2 is having the high sand content and the T1. It may be due to the hard. Then the sand content of the compost file ratio of the raw materials also showing the difference value in high value observed in T2 and the lowest value observed in the T1. When comparing with the standard is below than 20%, T2 and T2 having a little bit high than the standard. When saying the pH T1, so the lower amount of pH than the T2, and when saying the ratio of the raw material, C1 have the high pH. When comparing with the standard is 6.5 to 8.5, the C3 is showing a little bit lower amount of the pH. When seeing the EC, treatment 1 showing the higher value, and also when looking the ratio of the raw material, C1 showing the high value. When comparing with the standard 0.5, the standard is 0.5 to 3, the all treatments are under the standard. Then the total iron, this is the main part of my research. When seeing the treatment wise, treatment 1 is showing the lowest amount of nitrogen, and also treatment 2 having the highest amount of nitrogen due to the moisturizing solution and nutrition content. And when seeing the ratio of the raw material, C1 having the high amount of nitrogen. In here, which method having the high amount of plant material from the high nitrogen content. When seeing the enrichment process, E2 having the high amount of nitrogen. E2 means enriched with the fish-toning having the positive effect of the enrichment process, and is showing the high amount of nitrogen content. When comparing the standard is greater than 1%. In here, E2 and E2, it means enriched with the fish-toning enrichment process showing the positive value, and also the moisturizing solution with moisturizing solution while using the decomposition solution shows the positive value. And then the phosphorus content in here, T2 shows when treatment wise, T2 showing the higher value, and ratio wise, say ratio of the raw material wise, T2 equal ratio shows the higher value and enrichment results are also lead to systemic showing the higher value. When comparing the standard is greater than 0.5%, all the treatments will show that under the below all the treatment were shows that good value. Then the total potassium content in cleaner T2 showing the higher value and also an enrichment result T2 showing the higher value. When comparing the standard is greater than 1%. In here, all the treatment were under the standard. So here must be enriched with the potassium-rich raw materials. And also when seeing the organic carbon content, T2 having the higher value, and while when seeing the ratio of dry materials, T2 having higher value, the organic carbon content highly related with the raw material. When comparing the standard is higher than 20%, but here the C1 has a little bit higher, it is a bit lower in the standard. Then carbon 19 ratio. Then here T2 showing the higher amount and also C3 when seeing the ratio of the raw material C3 and the higher one. When comparing the standard is 10 to 25%. The standard is 10 to 25%. The C2, the C3 is showing little bit higher than the standard. And the reason for the CN ratio, when seeing the animal is high, the animal is high, the CN ratio will go high. Then the conclusion, composting with enrichment sources like from farmer's point of view. Enrichment with the organic fertilizers helps to increase the quality of the compost. And along the treatment with the decomposition solution shows the better result. The enrichment process of the compost with the fish tonic enhances the nitrogen content as 1.2%. Then the future reaction, the experiment was conducted with the different raw materials and different ratio of the raw materials. The different organic fertilizers can be used for enrichment process as potassium-rich materials. These are the reference. Thank you.
Thank you, Lavina. This presentation is now open for discussion.
Hello, Lavina. Hello?
Yes, sir. Yes, sir.
Actually, we can't hear your voice. We were unable to hear all the voice presentation. But the thing is, what is your treatment 2?
Treatment 2 is moisturize with the water and the ratios is a 1:2, sir. Plant material to animal manure 1:2.
What are the raw material used?
Raw materials, plant materials are glycerin and sunflower, wild caught sunflower, and animal materials are cow dung and poultry manure. Then other materials also added, sir.
Did you use fish tonic also?
Yes, sir. After the maturation, maturation, all part of the compost are separated, divided into 3, sir. And one part was added with the fish tonic, and one part was added with the Panchagavya. Then other part normal, without any enrichment process.
What is the nitrogen source between the treatment 1 and 2?
Sorry, sir.
There are 2 treatment, no? Treatment 1 and 2, no? Is it?
Yes, sir. Yeah.
What are the nitrogen sources differ from treatment 1?
For the treatment 1, sir, I moisturize with the water, and treatment 2, I moisturize with the decomposition solution.
Then
Then
only you got the
finally,
results.
then finally also, sir. Yes, sir. Sorry,
Okay.
sir.
Did you go for any cost analysis? You didn't.
Yes, the main point of view was the farmer, sir. My research I did in RARD Sikilinogy. So that main point is for my research is compost making for farmers, so that I
Okay. Yeah.
take
You have to go
very
for,
cost low.
no, it is better to go for
Sorry,
cost
sir.
analysis also, no?
Yeah,
Okay.
sir. Yeah, it's better.
Okay. Thank you so much.
Thank you. Thank you, sir.
Lavina, in your
Yes, sir. Yes, madam.
presentation, what you have concluded, which treatment is the best treatment?
When using moisturizing solution as decomposition solution, and for when using the enrichment process, fish tonic, the using of fish tonic, this is the best treatment for enrichment.
Yeah, that is, you are using fish tonic also. Is that cost effective? The cost behind
Yes, madam.
reduction will be.
Yeah, little bit high, madam, but I try to reduce the cost. I go to the market and I take the fish wastages, then I prepare the fish tonic.
Then okay, because otherwise that farmers can't do that, no, because the fish tonic is costly.
Yeah, madam, yeah.
Okay,
Okay, madam.
any,
Yes, Ms. Lavina, now may I have another clarification now? How did you prepare your samples for potassium determination? I mean the method of analysis.
Yes, sir. For potassium analysis, I expect.
Is it a kind of an extraction procedure or digestion procedure, in other words?
Potassium, it's wait. The dilution procedure, sir.
Sorry,
Dilution procedure, sir.
dilution or is it acid digestion or a kind of a extraction like using ammonium acetate like that?
No, sir. For acid, I'm not using acid, sir. For with a flame photometer, I did,
Yeah.
sir.
The extraction procedure.
Before the
Yeah.
for extraction, I did after the oven trying, sir. Did dilute with the ammonium.
Okay, acetate.
Yeah, sir.
Ammonium acetate extraction. No, you did ammonium acetate extraction. That means now again you mentioned your results as total potassium, right? So again, that is wrong. Because since you have extracted with ammonium acetate, the data is given as exchangeable potassium, right? That's not total, the exchangeable potassium, right? Similarly, what's the method that you use for phosphorus determination?
Spectrum photometer method, sir.
Is it extraction or digestion?
It is the extraction, sir.
Using what was the chemical that you used for that? Remember?
Chemical was potassium chromate.
It can't be. Did you use sodium bicarbonate?
Yes, sir. Sodium dicarbonate. Sorry,
okay,
sir.
Then again, it's extraction process, right?
Available
so
phosphorus.
Means, it relates to available phosphorus, right?
Yes,
okay.
Yes,
so please correct that one. Those two, exchangeable potassium and available phosphorus. You have determined, right? Okay. Thank you.
Thank you, sir.
thank you, Lavina.
Thank you, madam.
We'll move to the fourth presentation by Daniel. Daniel, are you here?
Good afternoon, all of you. Here I'm going to present the research study on production of quality compost using locally available resources. Nowadays, the compost is a major source of organic fertilizer and high demanded product in agriculture. And it's an inexpensive nutrient source and a natural process that transforms your waste into valuable and nutrient-rich product. And compost is plant nutrient, but also it acts as a soil conditioner. Therefore, the use of food is considered as essential in the sustainable agriculture. See the problems, why this research is important. In the situation, the fertilizer and fertilizer importations are reduced to the COVID-19 pandemic situation and the economic crisis situation. And the availability of commercial compost quality is low in terms of nutrient content, slow rate of composting, high C/N ratio, and high due to inappropriate production method. So let's think, we have any possible solutions to all these problems based on the literature review. So we can incorporate suitable and quality raw materials, can formulate the compost share based on the C/N ratio, and the ideal one is 30:1, or in between the ratio 25:1 to 41. And we can incorporate appropriate microbial source to reduce the decomposition time, and use cement floor or any polythene covered floor to reduce the sand percentage. Let's see the suitability of locally available raw materials. Cow dung, it's an excellent soil amendment capable of increasing the soil quality. Palmyra leaf and banana leaf after harvest, both are the underutilized resources, in phosphorus as well as potassium respectively, and goat manure, high amount of nitrogen and other nutrients. Poultry manure providing macro and micronutrients. Glycidia is a good nutrient source and it serves as a nitrogen source. And paddy straw, rich source of carbon. Panchagavya, it's an organic product that reduces the decomposition time. Therefore, this study was taken to convert the animal waste and underutilized plant residues into a valuable organic fertilizer. So the overall objective of this research study is to produce a quality compost using locally available resources, and specific objectives are analyze the physical and chemical properties of produced compost and compare the produced compost with Sri Lankan standard. So the research study was done in the Integrated Farm Training Center, and laboratory works was done in the Department of Agricultural Chemistry, Faculty of Agriculture, University of Jaffna. These are the raw materials used for the compost production: palmyra leaf, banana residue, glycidia, grass or yard waste, cow dung, goat manure, paddy straw, poultry manure. And the initial raw material analysis was done based on the standard laboratory techniques. Here, for the total phosphorus and the total potassium, the acid digestion method was followed. And the bed size of the pile is 5 feet into 5 feet into 5 feet size. Initially, the raw materials were collected and chopped into small pieces with the help of machine to increase the surface area. After that, the pile was made and it was covered with a polythene. And in a frequent interval, the turning and watering was done. After that, it was allowed for maturation by spreading. Then the 4 millimeter sieve was used to separate the compost, and it was packed. These are the treatments selected for the research study. Treatment 1 and treatment 2 almost same. It consists cow dung, glycidia, palmyra leaf, banana, and paddy straw. In the treatment 2, additionally 20% panchagavya was added. Likewise, treatment 3 and treatment 4 almost same. Cow dung, poultry manure, palmyra leaf, banana, and paddy straw. In treatment 4, additionally 20% panchagavya was added. In treatment 1 and treatment 2, glycidia was added. In treatment 3 and treatment 4, instead of glycidia, poultry manure was added. In treatment 5 and treatment 6, both are almost same. Treatment 5, cow dung, goat manure, palmyra leaf, banana, paddy straw, and grass or yard waste. And treatment 6, additionally 20% panchagavya was added. Based on the C/N ratio of the raw materials and the availability of the raw materials, treatments were decided. These are the amount of each raw materials added for each treatment combination. And the monitoring of compost pile, the temperature was taken using the compost thermometer, and in every day in 3 locations, and turning was done in two weeks interval. and the moisturizing was done in 5 days interval, and the hand squeeze method is used to determine the moisture level. And sampling was done by 5 random samples from the file, and it was mixed well, and it was followed with the quartering method. The compost analysis, basically physical and chemical properties were determined using the standard laboratory techniques. Statistical analysis, the data was statistically analyzed using statistical analysis software, and Dunker's multiple range test was used to compare the means. Let's see the result and discussion. When we consider the color and the smell of the compost in different treatments, all the treatment shows the blackish brown color, and Ola odorless, which means Ola satisfied the Sri Lankan standard requirement. For the organic carbon content of the compost, the Sri Lankan standard requirement is greater than 20%. All the treatments satisfied the Sri Lankan standard requirement, and treatment 6 show the highest one. Anyhow, there were no significant difference between treatment 1, 3, 4, 5, and 6. Nitrogen content of the compost in different treatments. The standard required Sri Lankan standard is greater than 1%. Here also all the treatments satisfy the Sri Lankan requirement, and treatment 1 gave significantly higher nitrogen value, and treatment 6 compared to all treatments, treatment 6 give low nutrient value. Anyhow, all the treatments satisfy the Sri Lankan standard requirement. C/N ratio, the required range is between 10 to 25. Here also all the treatments satisfy the standard requirement. pH, the standard value is between 6.5 to 8.5, and the pH also satisfied for the Sri Lankan standard requirement. Phosphorus, this is the total phosphorus content, and the Sri Lankan standard level is 0.5%, greater than 0.5% in terms of P2O5. Here, the treatment 4 gave significantly higher value in terms of phosphorus content, and treatment 1 gave the lowest value in terms of phosphorus content, total phosphorus content, and the standard is 0.5. So all the treatments satisfied the required amount. Potassium content, the standard value is greater than 1%. Here also all the treatments satisfied the Sri Lankan standard. Treatment 4 gave highest value. There were no significant difference between treatment 3, 4, treatment 5, and treatment 6. Sand content, the standard value is less than 20%. All the treatments satisfy the standard level, because here the cement floor is used to prepare the compost file. Decomposition rate, all the treatments satisfy the decomposition requirement, which means greater than 80%. So when we consider the Sri Lankan standard and all the physical and chemical properties, all the treatments satisfy the Sri Lankan standard requirement. And if we consider the phosphorus, total phosphorus content, treatment 4 is the best one. For the nitrogen content, treatment 1 is the best one. For the potassium content, treatment 4 is the best one. And for the organic carbon content, treatment 6 is the best one. Out of 6 treatment, compost treatment, highest nitrogen content were recorded in treatment 4. Cow dung, poultry manure, palmyra leaf, banana residue, paddy straw, and 20% Panchagavya treatment. All the compost treatments satisfy the Sri Lankan standard. Therefore, depend on the availability of the raw materials in the farm, farmers can choose any of the compost treatment out of 6 to produce the quality compost. This is the suggestion for the further study. Assess the effect of the produced compost in the field trial. Thank you for your attention.
Thank you. That presentation is now open for discussion.
Okay. Your treatment 4 is you are recommending good one, no?
All the treatments are satisfied with the Sri Lankan standard range, sir. But based on the nutrient content, treatment 4 is better than.
Yes. the same question asked the previous one also, but you have to go for the cost analysis also, no? You used cow dung, poultry manure plus pistonic, no? Is it?
No. Pistonics.
Cow dung, poultry manure, both were used in treatment for?
In treatment for cow dung, poultry
Only cow
manure,
dung.
both cow dung, poultry manure, palmyra residue, banana residue, and Panchgavya solution.
Oh, then go for the, when you go for the large scale production, it definitely affect the cost, no? Is it?
Yes, sir, but we can collect these things in the farm level, no?
No. For the large scale, in your area, for example, one tractor load cow dung, how much cost?
20,
You know the price?
20,000,
Yes.
50.
More than 20,000. Even for poultry manure, more than that. Then if you go for the to produce 1 kilogram of compost, it will cost high, no? See it? Then only farmers normally they are facing the cost of production is a very big problem, no? Then they would to reduce the cost. When we are considering the high nutrient content, better to reduce the cost. My suggestion is better go for the cost analysis also. Okay.
Okay, so thank you for your attention.
So here your topic is the production of quality compost using locally available resources. But
Yes, ma'am.
here you with the locally available resources, you are enriching this with what you have used to enrich the compost?
Panchagavya.
Panchagavya. So for the Panchagavya production, you have to add some costly components, your ghee and so how much is the cost for Panchagavya production?
It's the milk, ghee, cow urine, cow dung cost is compared to, sorry, miss. For the milk and cow dung, cow urine cost is low when we compare with the ghee cost. But here the application percentage is 20%, and for one pile, only goes added.
Percentage, what is that percentage?
Percentage Panchagavya, 1 liter was added for around 150 kg.
Then the cost will be lower.
The preparation cost is high, but the application rate is low.
Low, right. So can be recommended for the farmers, is that?
Yes.
Will they accept? And you have to go plant, then you have to check whether the organic, the compost can be used alone, sold in the field, or you have to combine with any chemical fertilizer. What your recommendation? Is that sold, that is the pure organic or combination of organic and chemical?
For the paddy cultivation, we applied this compost as whole one, and we gave positive response for that one.
Paddy cultivation, and which stage you have applied the organic manure? Initial stage. Then have you added the chemical fertilizer, urea and other things?
No, ma'am.
Without adding anything, the yield, how much is the yield?
We gave this compost for the Hanaharayam farm, the trial.
Is that yield is comparable with the yield by using chemical fertilizer?
Yeah.
Then the nitrogen, how much is the nitrogen content in the compost? Nitrogen percentage. 2.5. This is the available one, no? Available nitrogen content.
No, total.
Total nitrogen. In the compost, this is the total nitrogen.
All nutrient are phosphorus, potassium, and nitrogen. All are total.
Okay. Anything that in there?
Could you please get into the phosphorus variation slide?
Yes, sir.
Phosphorus.
Phosphorus
Variation
table.
of phosphorus.
Phosphorus.
Variation.
Yeah, the graph, okay, this one, yeah. Now, according to this, you're finding T4 give the highest phosphorus content. Is there any, can you explain why is it giving the highest amount of phosphorus? Can you reason out why?
In the treatment, T4, the poultry manure is the treatment 3 and treatment 4 are the combination of cow dung, poultry manure, Glycidia, palmyra leaf, banana, and straw. In the treatment 4, additionally, the Panchagavya was added. Maybe the effect of that one gives the high phosphorus. The further study is needed for this one.
Effect of Panchagavya. Is it, you mean, how the phosphorus content comes into a higher level in a process like composting?
Yes, sir.
So how the phosphorus content affect with the composting process, you know, that, can you explain?
So, based on the raw material.
Yeah, based on the raw material, yes.
Yeah.
So organic acids, no, develop in the process. It will dissolve the constituents, and as a result, the content, phosphorus content may enhance, right? Okay, okay, thank you.
Okay,
Thank you. Thank you, ma'am.
thank you so much. So with this, we are the first panel is we have completed the 4 presentations in the first panel. So the second panel, Dr. Duminder, the table is over to you. You are the chairperson for this panel. Dr. Giridharan and Sivan is not here.
Are we continuing in this way without
yeah.
break or?
Well, I'm not mostly What about you, sir? What about you?
I don't know about the others panel members and
We are continuing, miss? No.
Asking
yeah.
whether do you want any break for lunch?
Yes, if it is get the break, it's better.
Right.
can we have a 20 minutes break? Shall we start?
Okay, 20 minutes enough.
Ah,
Enough, okay.
Yeah, we'll start at 1:30 then.
Okay.
Okay,
we will
thank you
keep
so
the-
much.
Presenters, we will start at 1:30.
Yeah, we can keep the Zoom schedule as it is and
Okay, miss, okay.
Okay.